Okay. I don't know, we're coming over the west there, and they want you to come back in now.
Roger, we've been trying to talk to you for a while here.
No, back in. Come on. We still got 3.5 more days to go, buddy.
(1965) marked the 15th year since scientists first used this triangular tract of scrubland for missile testing. Today, Cape Kennedy is the focal point of the United States commitment in space. The year opened with two pieces of unfinished business. Mariner, a complex spacecraft launched on November 28, 1964, was in the early phases of a 350-million-mile journey to the planet Mars. And GT-2, the unmanned Gemini spacecraft, still sat atop the modified Titan II booster on Complex 19 after a December fizzle. These missions were completed. GT-2 was successfully launched in January. In July, Mariner zeroed in on its target to give scientists the first close-up pictures of Mars. 1965 was the year of promise at Cape Kennedy. Promise for real achievement in manned spaceflight. Promise for a military boost in space with the first flights of the Air Force Titan 3C. Promise for more muscle for the nation's deterrent strength by refinement of the latest ballistic missile weapon system. Promise for advancement across a broad front of scientific investigation with unmanned satellites. The programs at the Cape, which only a few years ago were science fiction, are today becoming science fact. This is the Thor Delta rocket at work. It evolved from an early Air Force weapons program and is now an operational space booster used by Air Force and NASA for most satellite launches. The satellites launched in 1965 gave the U.S. valuable scientific information to study magnetic fields, cosmic rays, radiation, and solar flares. In other applications, satellites launched gave us accurate details about the Earth's topography. They provided live television and communications between continents. And pictures from space to aid weather forecasting. This solid fuel, Blue Scout, hurled a small gold-plated satellite deep into space to measure the uncharted regions of the Van Allen radiation belt. It was one of 5 launched in 1965. In another sharpshooting demonstration, an Air Force industry crew launched the third trio of nuclear detection satellites aboard an Atlas Agena.
2, 1, 0. Ignition.
The satellites were injected into separate orbiting positions to serve as electronic sentries in space. The programs at the Cape vary, but one basic mission has not changed: the development and refinement of weapon systems vital to the defense of the United States and the free world. Minuteman II, America's most advanced intercontinental ballistic missile, continued testing during 1965. SAC's operational version will have a striking range of over 7,000 miles. At the Eastern Test Range, the missile is fired to a target area near Ascension Island, approximately 5,000 miles away.
Holding momentarily. AGO switch to proceed. Proceed. Guidance monitor.
Number 1, go.
LSO.
LSO, go.
-4, mark. 3, 2, 1, 0.
Seven Minuteman missiles were fired during 1965. All were successful. A different concept in weapon systems is the U.S. Navy's Polaris, launched from nuclear-powered submarines. Staging from Port Canaveral, each new submarine moves to a position 30 miles off the Cape coast to put both missile and crew through operational tests. The third-generation Polaris has a range of 2,800 miles. During 1965, there were 57 major launches from the Cape. Not so many as in previous years, but more demanding in the areas of launch support, tracking, and data gathering. Cape Kennedy, the downrange stations, and instrumented ships and aircraft make up the 10,000-mile-long Air Force Eastern Test Range. The growing complexity of space missions requires a massive amount of support from the range. Control of satellites, compiling of information for study of rocket performance, monitor and control to ensure safe operations during missile flight. Transition from a ballistic missile testing center to a space operations center will continue as the demands of the nation's most ambitious space program gathers momentum, landing an American on the moon by the end of the decade. The National Aeronautics and Space Administration proceeded on schedule toward that goal in 1965. The Ranger project, completed that year, provided the pictures of the moon's surface that prove there are areas smooth enough for a landing.
All launch commit lights are green.
All recorded advance.
I have a commit arm light. Mark. Ignition.
The world saw on television what Ranger saw as it approached and hit the moon. But more information is needed for the manned landing in Project Apollo. Is the moon's surface solid enough to support the Apollo spacecraft? A NASA Surveyor spacecraft will find out. The Surveyor will be boosted into space by an Atlas Centaur. In a research and development test flight in March, a fuel valve malfunctioned and Centaur raised only a few feet. In a later flight, all systems perform perfectly, setting the stage for the Surveyor launching. flight testing of the Saturn I series, which began in 1961, ended in 1965 with a 10 for 10 record. Each of the 1965 Saturns carried a huge satellite called Pegasus as a bonus payload. The giant spacecraft with a 96-foot wingspread made up of paper-thin aluminum panels is designed to unfold in space to detect and report the distribution, size, and velocity of tiny meteoroids hurtling through space. The final Saturn I with Pegasus aboard was launched on July 30th. Onboard television cameras show Pegasus spreading its giant wings in space. Keeping pace with the progress of Apollo is the development of the NASA facilities at the Kennedy Space Center on Merritt Island, just west of the Cape. The Saturn V Vehicle Assembly Building, the mobile launcher, and the crawlers for transporting the 365-foot-tall lunar rocket are rapidly nearing completion. Man on the moon is one direction. However, military capability in space is also required. The space booster to fit this need must be powerful enough to place heavy payloads into Earth orbit, be capable of maneuvering in space, have a support system designed for a fast launch rate, and yet be economical. The answer was the Air Force Titan III rocket, a combination of liquid and solid-fueled engines. In this new concept, liquid fuel stages are assembled as a core vehicle in one of 4 bays of the vertical integration building.